Okay, so welcome to all of you. Today we discuss that is the revise the chapter 1 differentiation. Okay, so that means we will revise first the derivative. Okay, so you are familiar with the derivative. Okay, so let it be a real valued function defined on open interval or closed interval I. Let C belong to C with a member of I. Then we are saying that f is a differentiable at C if this limit h tends to C f of x minus C upon x minus C. This is same as this limit h tends to 0 f of C plus h minus f of C upon h. Okay, so last year you have seen this one. Okay, this definition you are familiar with this definition. Okay, but we are using this definition here. Limit x tends to f of x minus f of C upon x minus C. It exists. This limit is exist means this limit is exist. How you can convert this limit is like this one. Put x minus C is equal to h. Okay, so x is equal to what, then C plus h. Okay, as x tends to C, h tends to 0. Okay, so as x tends to C, h tends to 0. So then f of x, okay, f of x is what, C plus h minus f of C upon x minus C is equal to h. So both are the same here. Okay, so both are the same here. Okay, so you should remember this definition. Okay, so now we'll see some examples which functions are differentiable and which functions are not differentiable. Okay, so you know that this is the standard example that mod x is continuous everywhere. It's continuous everywhere, but not differentiable. At x is equal to 0. But not differentiable at x is equal to 0. That means this function is continuous at x is equal to 0, but this mod x is not differentiable at x is equal to 0. Remember that. Okay. So suppose if you define the function like this, f of x is equal to x square, x belongs to R. That means your domain of the function is this. So this function is differentiable everywhere and f dash x is twice x. This function is differentiable everywhere and f dash x is twice x. Okay. Now suppose your function is f of x is equal to x square, x is greater than 0 and 0 x is less than or equal to 0. Okay. So if such function is given to you, then this is a function is given to you. Okay. So here what the f is differentiable at x is equal to 0. This function is differentiable at x is equal to 0. Okay. So and this is what f dash x is what, f dash x is twice x, x is greater than 0 and 0 if x is less than 0. This is your derivative. Okay. So this is differentiable at 0, note that. So even though this is the step function, but it is differentiable at x is equal to 0. Okay. Now suppose if you define function like this, f of x is equal to 1 upon x, x not equal to 0 and 0 for x is equal to 0. Okay. So now this function is not differentiable, f is not differentiable at x is equal to 0. This function is not differentiable at x is equal to 0. But this function is differentiable at x is equal to 0. Because it is a polynomial we have defined here. But this is 1 by x. 1 by x. But f prime x is equal to minus 1 by x square if x not equal to 0. If x not equal to 0, then it minus 1 by x square. So for other than 0, it is. Next, suppose if you define the function f of x is equal to x square sine of 1 by x or cos of 1 by x. Okay, so x not equal to 0 and this is 0, x is equal to 0. You take cos, you take sine, doesn't matter for this one. Is differentiable for all x belongs to R. This is differentiable for all x belong to R. Okay, so note that this. So just we are saying that if the function is differentiable, not differentiable, just we are discussing that only. We are revising this. We don't want to prove this one now. Okay, so you can prove this one. Okay, so I have already proved this. Okay. So now, what is the relation between the continuity and the differentiability? Okay, so if f is differentiable and x is equal to c, then it is continuous at x is equal to c. That means if a function is differentiable, that is what? If f is differentiable implies f is continuous. That means if a function is differentiable, then it is continuous, but not vice versa. That means continuous function need not be differentiable. That means what? If a function is continuous, then it is differentiable. This is not true. This is not true. Continuity does not imply differentiability, but differentiability implies continuity. Okay, and you know the standard example is there. This is what? Mod x. Mod x is standard example. This is the continuous everywhere, but it is not differentiable at x is equal to 0. That means this is the continuous at x is equal to 0, but not differentiable at x is equal to 0. So that means what? Continuity does not imply that differentiability, but differentiability implies continuity. That means every differentiable function is a continuous, but continuous function need not be a differentiable. Okay, so you should note this also. Okay, so now if f is a differentiable function, then alpha f is differentiable function. If f and g are differentiable function, then f plus c is a differentiable function. Product is also differentiable function. If g of c not equal to 0, then f upon g is also differentiable at x is equal to c. If f and g are differentiable at x is equal to c, then f upon g is differentiable at x is equal to c. If g of c is not equal to 0. If g of c is equal to 0, then f upon g is not differentiable at x is equal to c. Okay, so note that this. Now, so you know the chain rule, that is g compose f c is nothing but g prime f of c f dash c. Okay, so this is the chain rule that you know. Okay, so we'll see some example on this. Suppose f of x is equal to x to the power 5, and g of x is equal to suppose the tan x. Okay, suppose tan x. Okay, now we want to find f compose g of this. Okay, so now f compose g of x, just apply this formula. This is what? F is here, this is g is here, so this is what? Then f prime g of x, f prime g of x into g prime x. We'll do also this is what? We'll find g compose f. This also for practice we'll do this one. Okay, so for this you need to find f prime x. F prime x is what? 5x to the power 4, and g prime x is what? Tan means derivative of tan is what? Sec square x. Is sec square x. Okay, so what is this then? This is f prime g of x. Your g of x is tan x. What is f prime something? So this is what? 5g of x. Okay, so replace x by your tan x now. Okay, so this is tan x raised to 4 into g prime x. What is g prime x? Sec square x. So you can write sec square as 1 plus tan square. You can write this, so that it will convert in terms of only tan. Okay, so now what about this? This is what? G prime f of x into f prime x. G prime f of x into f prime x. Okay, so your f of x is what? X raised to 5. Okay, g prime is what? Sec square. So this is what? Sec square. Your x is what? F of x, and f of x is what? X to the power 5 into f prime x. Your f prime x is what? Your f prime x is what? 5x to the power 4. So this is what? 5x to the power 4 sec square x to the power 5. So in this way you can differentiate like this. Okay, so this is the counter example I have provided here. So you can do, you can solve any for here. You can take cos x, log x, something like this. Okay, we'll do one more example. Suppose f of x is equal to x to the power 4 plus 3x square plus 2, and g of x is equal to suppose log x, okay, log x, log of x, okay, log of x. Okay, so we find g of f prime. So this is what g prime f of x into f prime x. So g is there, so g prime we have to take, note that. Okay, f is there, then f prime we have to take. First one we have to take the f prime. Okay, so note that this. So what we have to do this differentiation then. F prime x is equal to 4x cube, 4x cube plus 6x. Okay, and g prime x is what? 1 upon x. Okay, so we put here g prime f of x, g prime f of x. G prime something is 1 upon something. So this is 1 upon f of x. What is f of x? Is 1 upon x to the power 4 plus 3x square plus 2 into f prime x. So your f prime x I will write in bracket because there are two terms. So you can shift here. This is what? 4x cube plus 6x upon this. Okay. So here, in this way you can differentiate like this. So this is what chain rule. So you know that f from suppose b to b, r to r, suppose this is a function. Okay. So if f of x is equal to y, then f inverse y is equal to x. Or if you say this is what g of y is equal to x, then you are calling that g is the, okay. So that means what? G of f of x, g of x, what? G of f of x. So this is what? This is same as g of y, g of y. Okay, and g of y is what? X. Okay, and f of f compose g of x y. So this is what? F of g of y. Okay, g of y, and f of g of y, g of y is what? X. Okay, and f of x is what? Y. F of x is y. So that means what? This g compose f and f compose g are identity function. Are identity functions. Okay, f compose g. So function is invertible. That means there exists a function g such that g compose f and f compose g are identity function. Okay. So now we have to find like this. So then g prime d is what? 1 upon f prime c. 1 upon f prime c. Where d is equal to f of c. D is equal to f of c. And this is same as 1 upon g prime f prime g of d. G of d. So g of d is c now. G of d. G of okay. So d is equal to f of c and g of d is equal to c. G of d is equal to c. Okay. So that means they are invertible function. Okay. So g is what? G is the inverse of f. Okay. So now we take an example so that you will understand this. How the question will be asked on this. Okay. Suppose you have f of x is equal to x raised to 7 plus 3x plus 4. Okay. And you want to find f inverse of 8 now. Suppose you want to find f inverse of 8. This you want. Okay. So what is f prime x? Just we find f prime x. So 7x to the power 6 plus 3 plus 3. Okay. Now f of 1 is equal to 8 now. Okay. So put the proper value of x. So this is okay. So f inverse of dash 8 now. Okay. So this is 8 is equal to 1 upon f prime of 1. 1 upon f prime. Okay. Note this formula. You should know this. If f of 1 is equal to 8, then n inverse of this f inverse of 8 is equal to 1 upon f dash of 1. Okay. And what is f dash of 1? So this is 1 upon 10 then. 1 upon 10. Okay. So we'll take one more example. Suppose f of x is equal to x square. F of x is equal to x square. So then f inverse x is what? F inverse x is 2 root x then. Only root x. F inverse x is root x if f of x is this. Okay. So directly you can differentiate, then this is what? F inverse of dash of x is 1 upon 2 root x. Okay. Remember this. Okay. So if you take this example, suppose f of x is equal to x raised to 5 plus 7x plus 9 suppose. Plus 9 suppose. Okay. So you want to find f inverse dash of 17 suppose. 17. Okay. So you want to find this value. Okay. Okay. So f of x is this. Okay. This is given to you. Okay. So f prime x is equal to what? So 5x to the power 4 plus 7. Okay. So what is this f of 1? F of 1 is 17 now. F of 1 is 17. Okay. So therefore f inverse of dash 17 is equal to 1 upon f of 1. 1 upon, I have taken the simple value. Okay. You may take, suppose this is minus 1, then this is what? If you put here minus 1, then this is 1 also. Okay. Then it will be the 1. Okay. So you can find this is what? Minus 1, then this is f prime. This is f prime. Okay. So f prime, so this is what? 5 plus 7 is the 12. So 1 by 12. Okay. So we have to choose the proper value from the option. Okay. So note that for the derivative of the inverse function, such type of the problems may be there. Okay. Now suppose f of x is equal to x cube. What is f prime x? 3x square. Okay. Suppose g of x is equal to 1 upon x. What is g prime x? Minus 1 upon x square. Just will differentiate this. Okay. So that means what? Suppose f of x is 1 upon root x. 1 upon root x. Then f is differentiable. For all x greater than strictly greater than 0, not equal to 0 also. Okay. So x is positive only. Okay. Non-negative is not there. 0 is not allowed here. Okay. So 1 upon root x is differentiable for only the positive value of x. Okay. For positive value of x. So similarly, f of x is equal to root x. This is also differentiable if x is greater than 0, not greater than equal to 0. Okay. Not greater than equal to 0. Okay. So root of 0 is exist, but if you take the derivative, 1 upon root x is there, x is at the denominator. So this is what? X should not be 0 also. Okay. Not differentiable at x is 0. Okay. Suppose f is from R to R, defined by f of x is equal to x square. X is rational. And 0 if x is irrational. Okay. So then f is differentiable at x is equal to 0. So note that this f is differentiable at x is equal to 0. Now you can find this is what? Suppose f of x is equal to log of sine square x. F of x is equal to, suppose this is a to the power tan inverse x or e to the power tan inverse x. Okay. F of x is equal to this. We want to differentiate this. So what is this f dash x? This is what? Log of something. What is the derivative of log x? 1 upon x. So what is the derivative of log of something? 1 upon something. So 1 upon something. Sine square x. Into derivative of something. So sine square x. So sine square x means what? Sine of x bracket square. First we have to remove. First we have to pull the power. Reduce the power by 1. Right? And multiply the derivative of the bracket. So derivative of sine x is a cos x. So this is same as 2 sine twice x upon sine square x. Or you may write this is what sine. So this is what? 2 cos x upon sine x. Okay, so this is 2 cot x. Maybe the answer like this. Okay, maybe the answer like this. Option maybe this. Option maybe this sin twice x upon sin square x. Maybe 2 cos x upon sin x. Maybe 2 cot x. Okay, so the all possible answer you should write there. Okay, next a to the power tan inverse x. So what is the derivative of a to the power x? A to the power x into log a. So this is what a to the power tan inverse x into log a into derivative of tan inverse x. So derivative of tan inverse x is 1 upon 1 plus x square. Okay, so this will be there. If e raised to tan inverse x is there, then this is what e raised to x. Derivative of e raised to x is e raised to x. So this is tan inverse x into 1 upon 1 plus x square. Okay, so note that. So such type of the problem may be there. Okay, f of x is equal to, suppose f of x is equal to root of 5 minus twice x plus x square. Okay, so this is root of something. So f dash x is what? So 1 upon 2 root of something. So this is what? 5 minus twice x plus x square into derivative of something. So derivative of this is what? Minus 2 plus twice x. Okay, so you can remove this 2. So this we get what? Minus 1 plus x upon root of 5 minus twice x plus x square, or x minus 1 upon this. You can rearrange the terms. Okay, so you can choose your correct option from this one. Okay, so if f of x is equal to f of x is x upon 1 plus x square, then what is f dash x? So what? This is what? 1 plus x square. Denominator into derivative of numerator. Derivative of numerator is 1 minus numerator into derivative of denominator. This is twice x upon the square of the denominator. Upon the square of the denominator. This is minus twice x square. So this is what? 1 minus x square upon 1 plus x square bracket square. Okay, so you can choose your option from here. Okay. Now suppose f of x is equal to x raised to twice x. Suppose x raised power to the power is there. So what you have to do then? You have to do log of f of x. So this is what? X twice x into log x. Okay. Now differentiate this. This is what? 1 upon f of x. 1 upon f of x into f dash x. Into f dash x. So what is this? Twice x into 1 upon x log x into 2. Twice x is, this is the product, twice x into log x. Okay, so f dash x is equal to, what is your f of x? X raised to twice x. Just simplify this, 2 plus 2 log x. 2 plus 2 log x. Okay, so this is a simple example. This. Okay, so such type of the function may be there. You have to find the derivative of this one. Okay, so you are familiar with the derivative, so no problem for you to find the derivative of any function now. Okay, suppose f of x is equal to tan of x square. Tan of x square. What is f prime x then? What you can do? Tan of something. What is the derivative of tan x? Is sec square. So sec square something. Sec square something into derivative of something. So that is twice x. So twice x into sec square x square. Okay. So this is the derivative. So if f from R to R, f from R to R is differentiable, at x is equal to c, at x is c, and f of c is equal to 0, then g of x is equal to mod of f of x is differentiable at x is equal to c if and only if f prime c is equal to 0. F prime c is equal to 0. So note that this g of f of x is differentiable at equal to c. So what you have given? F from R to differentiable at x and f of c is 0. F of c is provided to you. If the value of f at c is 0 is provided to you. Then g of x is equal to mod of f of x is the differentiable at x. F prime c must, if f prime c is equal to 0, then only this is differentiable. Otherwise, it will not be differentiable. Okay. So note this theorem also. You should note this statement. Okay. Okay. So we have to discuss the differentiability. This. Okay. So suppose this is f of x is equal to mod x plus 1, mod x plus 1. So this function is not differentiable at x is equal to 0 and x is equal to minus 1. For what value of this is 0? Minus 1 this will be. For what value of this is 0? This is 0. Suppose if you have given this is mod of x is equal to mod of x plus mod of x minus 2. So then, okay, so here x plus 1 is there. Okay, so for minus 1 and 2, for minus 1 and 2, this function is not differentiable. Okay. Now suppose g of x is equal to twice x plus mod x. Twice x plus mod x. Okay. So now see, if x is greater than 0, then g of x is what? 3x. G of x is 3 because x is positive, mod of x is x. Okay. So g prime x is what? G prime x is 3 then. Okay. So if x is less than 0, then mod x is minus x. Then your g of x is what? G of x is what? X only, and g prime x is 1. Okay, but g is not differentiable. G is not differentiable at x is equal to 0 because mod x is there. You know that mod x is not differentiable at x is equal to 0. So this is what? G is not differentiable at x is equal to 0. Okay. Suppose this h of x is equal to x mod x. Again, this function is not differentiable at x is equal to 0. This function is not differentiable at x is equal to okay. So now this function is differentiable at x is equal to 0. Product is there. Okay, is differentiable at x is equal to 0. It is differentiable at x is equal to 0, and h prime x is 2 mod x. 2 mod x. That means what? H prime 0 is 0. H prime 0 is 0. Okay. So now f of x is equal to mod of sin x. Mod of sin x. Not differentiable at x is equal to n pi. That means for integral multiple of value of part, it will not be differentiable. It will not be differentiable. You should remember this. You should not be differentiable. We don't have to show that this is not differentiable at this one. Okay. So we want to remember only where it is differentiable, it is not differentiable. So if this is what? This is differentiable for values of not equal to n pi. If x is not equal to n pi, then it is a differentiable. Okay. Okay. So this also you should note one thing is what? Derivative of what is the derivative of r function? So you know that if f from r to r is the function, is said to be, so first, okay, f is even if f of minus x is f of x, and second, f is r function if f of minus x is equal to minus f of x, is equal to minus f of x. So what is the derivative of even function? Okay, so derivative of even function is an odd function. Is an odd function. So derivative of even function is odd function, and derivative of odd function is even function. Is an even function. Is an even function. Okay. So remember this. So if f is a differentiable even function, then it is and then g prime is the odd. Suppose this is f. Okay. So f is a differentiable even function. F is differentiable even function. Then its derivative is odd function. Then f prime is odd. Okay. So if f is differentiable odd function, then f prime is a even function. Note that. That means derivative of even function is odd function, and derivative of odd function is even function. So note this. Suppose we have this function g of x is equal to x square sine of 1 by x square, x not equal to 0, and is equal to 0, x is equal to 0. So what here? So what here? Instead of sine, you can take the cos also. Instead of sin, you can take the cos also. Okay. So G is differentiable for all x belongs to R. Remember this only. G is the differentiable for every real value. That is differentiable everywhere now. Differentiable everywhere. Okay. So here we have discussed all those things. So we don't have to remember how to prove that one. Just remember that this is not differentiable. Just remember that this is not differentiable. This is differentiable. At what point that is differentiable, and find some derivative like this. Okay. So you should remember this point. Okay. So now we stop here. Thank you.